hello everyone. Today we'll try to understand the concept of normalization in database management system. It's going to be a very interesting and important topic. As we know, most of the questions in the university exam as well as in the gate are asked from this particular concept called normalization. So let's try to understand what exactly we mean by normalization. So we need to perform or we need to make use of the concept of normalization whenever we go for designing of database. So we design a database by making use of ER diagrams and then transforming the entities in the ER diagram into various tables in the database. So when we try to create multiple tables, you may find that there is some amount of redundancy or there will be some amount of redundancy within our tables or the relations. So in order to avoid that, in order to organize the data in a database in a particular manner, we need to go with the concept of normalization. So it is a process which is going to help us to organize the data in the database. It helps us to reduce the redundancy. It helps us to remove the unwanted data and it helps us to eliminate the problems that we incur during the process of insertion, updation and deletion. What we term them as or call them as insert, delete and update anomalies. So whenever you design a database with multiple relations in a database, you will find some problems with respect to redundancy, with respect to insertion, updation and deletion. So these can be avoided by making use of the concept of normalization. So when we go with the concept of normalization, we see that a larger table, in the sense a table having multiple attributes, can be broken into, or we can divide that into multiple smaller tables and so on. And we can join these tables by making use of some relationship over there. The normal form is basically used to reduce, we can say, the redundancy from the database. The purpose, if you see, the purpose of normalization, as we said, a process of structuring and handling the relationship between data to minimize redundancy in the relational table. It avoids problems, as we said, with insertion, deletion and updation. It also helps us to divide a larger table into a smaller ones so that we can easily add the data, manipulate the data and so on. Normalization basically defines some rules for the relational table as to whether it satisfies the normal form. So whenever we design a database, we try to work with the concept of normalization, and then there are various forms of normalization which we need to understand. And then we need to see whether our relation follows or it satisfies the rules of these normal forms or not. Normal form is also a process that evaluates each relation against defined criteria and it removes multi-valued joins, functional and trivial dependencies from a relation. So what exactly we mean by multi-valued joins, functional and trivial dependency in a relation, we'll try to understand as we progress in this particular video. It will also remove the problems related to insertion, deletion of the data and so on. So if you go by an example, we'll easily understand over here why normalization is required. So I have taken over here a relation called student, wherein you have the roll number of the student, name of the student, address of the student, followed by the course ID, the course name, HOD name and the HOD phone number. And then whenever a student joins a particular college and a particular course in a college, we are going to enter the details of the student over here, like the roll number, name, address, course ID, course name, HOD name and the HOD phone number. Now if suppose say there is a new student who is going to join or who has joined the college, then you are going to enter the details in this fashion. So you will enter over there the roll number of the student, you will enter the name of the student, you will enter the city from where he is coming, then you will try to enter the course which he is going to join, which has a course ID, and then you will enter the name of the course over there, followed by the name of the HOD and the name or the phone number of the HOD. So, what is that you observe in this case is whenever a new student joins, you are going to enter over here every time the details about the course like course ID, course name, and then you are also entering the details like HOD name, HOD phone number, and so on every time. So, as and when a student joins, as and when you want to insert the data pertaining to a student, you are supposed to enter the details of the course, you are supposed to enter the details related with the head of the department, and so on. So, this is where you come across a problem related to redundancy. So, we need to avoid this redundancy by making use of the concept of normalization. So, what is that we observe over here? Whenever I try to insert the data over here, a data of a particular student, I am supposed to insert every time the course ID of the student, course name of the student, followed by HOD name and HOD phone number, wherein we can easily understand that for a particular course, there will be a particular HOD. But instead, we are supposed to enter the details of the HOD and the course every time along with the details of the student and so on. So this may take a longer time to insert the data pertaining to a student over there. So what you can term this as a problem that exists with the help of, or the problem that exists with insertion of data. Just try to understand this. When we insert the data in a student relation, we have to every time enter the details pertaining to the student along with the course and the head of the department, wherein the name and other details of the head are going to remain the same for a particular course over here. But in spite of that, you have to enter the details about the head and the details pertaining to the course. So this is going to take a longer time while you enter the data. And you also see that we are going to enter repeated data over here or redundant data over here. So there is a lot of duplicacy in the data that we are entering over here. So this is where you talk about redundancy. And this is what a problem we are going to face whenever you try to insert the details pertaining to a student. So what I mean to say over here in short, whenever I enter the details of a student, along with the details of the student, here in this particular table, I am also supposed to enter the course details, I am also supposed to enter the HOD details and so on, which is not required at this particular point of time and so on. So this is where I say there is a lot of redundancy, duplicacy of data in this particular table, and that is the problem we are going to face whenever you insert the data in a table. What do you term this as? Insert anomaly. Similarly, whenever you try to update the data in this particular table or the relation, when we try to change the details of the head of the department, for example, say the head of the department for a course called C01 has changed, and instead of ABC, you want to give the new name of the head as XYZ. So ABC has left the college and XYZ has joined the college and he is designated as the head of the department. So you have to change the name of the head along with the phone number. So then whenever I want to make the change, it is just not that I will change at one particular place, but I have to change it in the first record, in the second record, in the third record, and in the fifth record. So multiple times I may need to do the changes over here. And because of that, there is every chance that you may lose some updation or changes at a particular instance, and thereby your data is going to become inconsistent. So what I mean to say in short again, whenever there is a change in the HOD, I need to make the changes at multiple places over there. And if I am going to lose, or if I am not going to change at a particular point or a particular instance, then I will see that my data is going to become inconsistent. So that is the problem we face whenever you try to update the data, what you call it as update anomaly and so on. Similar is the case when you try to delete the data over there. So when we delete the data pertaining to a student, as in the case we have taken an example of roll number 4. So if I delete the data pertaining to this particular student, then you will see that along with the student data, you will also delete the data pertaining to the course. You will also delete the data pertaining to the HOD, that is head of the department. So when a student drops from a college, we don't have to drop the course, we don't have to drop the HOD. But in this case, when you delete this particular record, the details pertaining to the course and the details pertaining to the head are also getting deleted. So that is where we say it is a problem related to deletion of data. So whenever you have a data of this kind, wherein you have the details of a student followed by the course, followed by the head, then you will see a lot of problems with this in terms of redundancy, repetition of data, and in terms of problems with respect to insertion of the data, updation of the data, and deletion of the data. So if we want to avoid all these anomalies, then we are supposed to change this table. We are supposed to bring the table into certain normal forms. So as we progress, we are going to discuss about the various normal forms in this video. So before we understand what exactly is normalization all about, before we convert or before we understand whether a table or a relation exists in a first normal, second normal, and the other normal forms, we'll try to understand some of the basics that are required in order to perfectly understand what is normalization. So unless otherwise I understand the concept of functional dependency, unless otherwise I understand how to find a candidate key, I may not be able to understand the concept of normalization perfectly. So let's start with understanding the basic concept called functional dependency. So what exactly we mean by functional dependency, and when is that we say there exists a functional dependency from X to Y, A to B, and so on. So if you consider that there exists a functional dependency from A to B, and if the values of A and B are given to us in this fashion, we'll try to understand in which case there exists a functional dependency and in which case you do not find a functional dependency, and so on. So when I say functional dependency, it means that for any given value of A, I must be able to find or compute or search the value of B. So for example, say when the value of A is 1, I am going to get here the value for B as A. Similarly, for value of A as 2, I am going to get the value for B as B. Similarly, when the value of A is 3, I am going to get the value for B as C, and so on. So for any given value of A, I am able to search the value of B. Then I say a functional dependency exists over here from A to B. So let's understand the second example over here, wherein the values of A, if you see, they are getting repeated, and the values of B over here are the same. They are constant. So now whether there exists a functional dependency over here or not, we need to check for it. So whenever I give a value for A, do I get a value for B? The answer for that is yes. When I give the value for A as 1, I am going to get the value for B as 1. When I say the value for A is 2, I am going to get the value for B also as 2 every time. When I say the value of A is 3, I can search the value of B and it is 1 every time. When I say the value of A is 4, I am going to get the value for B as 1 every time, and so on. So then I will say functional dependency exists over here from A to B. Okay, next we'll take the case wherein you have functional dependency from A to B. In this case, the values of A are constant and the values of B are getting changed. So that means when I give the value for A as 1, what is that value I get for B? I'll get the value for B as A, I'll get it as B, I may get it as C, I may get it as D, E, F, and so on. That means there exists no functional dependency in this case, because for a given value of A, you are getting different values of B over here. So there we say functional dependency do not exist from A to B. Okay, let's try to understand in this case. So here if you see the values of A are repeated 1, 2, 1, 2, 1, 2 and so on. Similarly, the values of B are also repeated. So what is that you need to see over here is for a given value of A, do you get a value for B or not? And it should be same in all the instances. So when I give the value for A as 2, I'll get here B, here also I'll get B, here also I'll get B. So here we say functional dependency exists from A to B. So functional dependency exists from A to B in case for a given value of A, you should get the same value for B every time. So in short, we can say that by looking at these four different relations, you can say that a functional dependency exists from A to B when all the values of A are distinct. When all the values of A are distinct, irrespective of the value of B, we get the functional dependency. Whereas it is also possible to say that when the value of B is constant, irrespective of the value of A, there exists a functional dependency from A to B. Okay, so two cases we are trying to say over here. One is that whenever the value of A is distinct, whenever the value of A is different, irrespective of the value of B, we can say that functional dependency exists from A to B. The second case, whenever the value of B is constant, irrespective of the value of A, we say a functional dependency exists from A to B and so on. So that is how we need to understand the concept of functional dependency, and this is going to be very important for us when you go with the concept of normalization. Thank you. We'll try to understand the different normal forms in the next video to come. Thank you.